Hello guys, so in this video we're going to look at the two important things to consider when finding both the domain and your range. Okay, in this case we are not going to sketch, we are just going to just go ahead and find the domain and range from the name of the function that is given um, in terms of x. And maybe they will say f of x will be given in terms of x, and you want to find that domain. Okay, it's not only these two that they like to assess, but the one thing again that it's not only these two that they like to assess on, and you must again check the absolute values as well. Okay, but that we will discuss if we encounter a problem like that, maybe towards the end of this video. For now, let's just look at these two. Number one, you must know that the even root of f of x, if you have something like this as your function, your f of x, you don't want it to be negative. It can never be negative, okay? Not negative. So it must always be greater than 0 or equal to 0. If it's equal to 0, then the square root of 0 is just 0. If it's greater than 0, then it will be defined. But if it's less than 0, if you let f of x to become negative, you don't want that. Now let's look at our second one here. It says 1 over f of x. So let's say it was g of x, okay, it being equal to that. We want to avoid all the cases that will make our f of x to be equal to 0. So we don't want our f of x to be equal to 0. So you start by writing f of x must never be equal to 0, and then you proceed solving from there. You produce some value. Let's say you produce some value a and some value b from those. Maybe x must be between a and b, okay? Now let's look at our next topic, that is finding the range based on the values of x you found from the domain. Okay. Now it turns out after finding the domain, it's going to be fairly easy for you to find the range because now you have a and b. Now finding the range is simply finding the limits. Finding the limits as x goes to either a or b. Let's say a from the right or from the left side of f of x. It really depends on where the function exists. We will see when we answer the questions that will follow these examples, okay? You want to check again the limit as x goes to plus or so that those limits will determine the behavior of the function within the given domain, the domain that you solved up there, okay? The domain that you solved up there, you want to check the behavior of the function as you go for those domains a and b, or plus and minus infinity as well. And then after checking that, then you can identify the range. We have a special case where you have to find the critical equals to our special case of y, let it be equal to g of x. Okay, we want to do what? We want to find the critical values. Finding the critical values will be you finding first the first derivative of g. Finding the first derivative of g will be you finding a new function, maybe h of x. Okay, you want to do what? You want to take h of x, equate it to 0, and find the values of x that will make h of x to be 0. You produce maybe e, g, and f. You want to check the behavior of the function as x goes to e, d, and f, both from the right and from the left of e, d, and f. We will see the problems. Don't worry. If you don't understand what are we talking about, we will see the problems in the coming future. In the coming future of this video, okay? And then you can determine the range from there. In case like a parabola that is being restricted 4, or let's say x squared minus 4. You want to sketch x squared minus 4 from minus 2 to 2. They say to you, you must sketch this. What will you do? You're going to sketch something like this. That will be your 2 minus 2, and this will be your 2 here. Now you want to sketch something like that, go into that 2. The problem with 2 and minus 2 is that when you find the limits, remember 2 and minus 2 are like a and b there. When you find the limits as x goes to minus 2 and 2, we are going to get the same answer. The limit is going to be 0. But now, look at this one. It says the function increases in between 2 and 2. The function goes up like that and then go down after a certain value that is maybe 0. Yeah, probably 0 in this case. It will decrease after that. So the range is not only ranging from 0 to 0. The function ranges from 0 to some value there up there. The function will be coming to cut here at at y equals to 4. Why is it cutting at positive 4? Because remember we said this function we are going to make it an absolute function. Okay, we're going to say y, let it be equal to minus 4, and that's why
X
it will
squared.
cut at positive 4 on the y-axis. Okay, now we have to find that 4. To find that 4, you want to take the derivatives. Now you have to take the derivative, first derivative equated to 0, and find the values of x that will make that to be true. Okay, now let's look at some problems. The first question that we deal with here says find the domain and range of the following function. Or you want to find the domain of f prime of x if f of x is the square root of x. Okay, they will do that. That's what they like to do. They like to ask questions like this. They give you this one and they want the domain of this one. So they want you to know that you must think, I have to use that one to find that one and then find the domain of that one. Okay, now let's look at it. So we start by saying f of x is going to be the square root of x. Eh, This implies that f prime of x is going to be 1 over 2 the square root of x. How do we get that one? How do we get it? We say since f of x is equals to x to the power of 1 over 2, remember this just simplifies to be x to the power of 1 over 2. Okay, now you want to take the derivative. The first derivative of f of x will be 1 over 2 times 1, that is 1 over 2, x to the power of 1 over 2 minus 1, that is minus 1 over 2. This is your first derivative. Rewrite it, rearrange it, you get that thing. That is 1 over 2 x to the power of 1 over 2. But that x to the power of 1 over 2 is in the denominator, and therefore it's just the square root of x. So we write it like that here. Since our first derivative is that, let's find the domain of that new function that is our first derivative now. Our domain for that function is that we know that under the square root, we must never have a negative number. So we know that x must always be greater than 0, but also equal to 0. But since in this case it's part of the denominator, if it becomes 0, if we let it to be 0, we are going to have a problem. That f prime of x is going to be undefined. Our new function, that is the first derivative of f, is going to be undefined. And therefore, we cannot do this here. We cannot put but also equals to 0 for that function. The answer for this question is, for the domain of this question is x must always be greater than 0. So this is just your answer, not this one. Okay, the answer would be this, provided that square root of x was part of the numerator in your fraction, like this one here. Then we can say answer will be x is greater but also equals to 0. In this case, it's just greater than 0 because we want to avoid an undefined case that will be 1 over 2 times 0, that is just 1 over 0, that is undefined. Okay, the function is undefined at x equals to 0. Now let's find the range. Finding the range of this function will be as taking not of f of x but that of f prime of x. Okay, but we want it where? When x goes to what value of x? We only have one condition here, one value of x that gives us one condition there, that is 0. So we approach 0 from which side? The domain says the function only exists for the values of x when x is greater than 0. So we want to, the function only exists here, 0. The function only exists from 0, that side. Okay, so we want to check the limit as we go to 0 from that side there, this side of 0, there is no function that is existing there. The function, our function only exists to the right of 0. Remember, this condition simply means what? Simply means we have an interval looking like that. We have 0 there, and then we have infinity. Our function exists only this side. Okay. Now we're gonna check what's happening at 0 and at infinity, and then we can give our range based on that. So we say we take the limit of 1 over 2 the square root of x, that is our f of x, as x goes to 0 from the right. We want to come from the right of 0. Okay, we want to come from the right of 0, approach 0, and check what's the behavior of the function. The limit will tell you that. Now, this limit is those ones that you solve by interpreting what's going to happen as you go to 0. Because if we substitute 0 here as our x, we're gonna have a problem. We're gonna have 0 as the denominator. But what we can do is at least determine what's the behavior of the function as we go to 0 from the right. If we substitute 0.000001 here, we are going to get some solution that is a very big number. And as we put a number that is smaller than 0.00001, the one that is less than the one that we inserted there previously, okay, we're going to get a very large number again as our final answer. Now, knowing that, that's how you interpret this question. The answer to this question will be, we're gonna have 1 divided by, remember, we are putting here a very small number. It's going to produce a very small number here in the denominator. We're going to multiply 2 with a very small number. The resulting number, a very small number, will simply mean 1 over, maybe 1 over 10. We put 1 over 10, we put 1 over 100 after, we put 1 over 1000 after, and so on. We keep on adding these zeros, we keep on putting it there. That number is going to be very small. It's going to grow very small. It's going to grow small until as we keep on approaching 0 from the right. Okay, now that small number, as we multiply it with 2, it's going to produce a very small number there. It's going to make our answer here in the denominator to be a very small number. Okay, I'm just going to write a very small number that we don't know, because those numbers are very complicated. 0.0001 multiplied by the square root of that multiplied by 2 is going to be very small again. So we're just saying, as we replace this x by a very small number, we are producing a very small answer in the denominator. Now, if you have a constant c divided by a very small number, a number that is approaching to be 0, is this number, remember, it will never be 0. It just wants to be 0. It goes as far as possible to become 0, but it cannot be 0. Okay, that small number, we put it here, we produce infinity, a very big number. Imagine dividing a constant 10 by 2, you get 5. Divide the very same constant 10 by a number that is smaller than 2 now, 1, you get 10. You see now what's happening with our answer. Our answer is increasing. Divide 10 by 1 over 2, you get 20. Divide 10 by 1 over 4, you get 40, like that. So the answer is increasing as your denominator is becoming small. Your answer is increasing. Your answer will keep on increasing up to infinity then. We say, since this number is smaller than even 1 over 2 or 1 over 4, that we keep on substituting here. The answer, when you divide any constant by that answer, is going to increase infinitely so, and the answer is just going to be infinity at the end of the day. Okay? Now we know that as we approach 0, the function, as we approach 0 from the right, from this side, the function must be going up like that. Because as we go to 0, the function value, the limit of the function goes to infinity, a positive infinity. Let's check what's happening with the number as we let x to approach a positive infinity now, because this is, again, remember, the function exists here. Now let's check, when we go that side to the positive infinity, what's happening with the answer, right? The limit of f of x, that is our 1 over 2 square root of x as x goes to infinity. You write infinity here. We know that when we attack infinity, we only attack it from the left, okay? So there's no need for us to put a negative on top of that infinity there. When we attack a negative infinity, we approach it from the right. So there's no need for us to indicate that we are approaching negative infinity to the power of a plus there, okay? There's no need for us to write there. Just replace x with infinity. This one we can do. We can do. We are allowed to do this one. Just again, it's a basic interpretation of of these things. 1/2 the square root of x. Let x become infinity and see the behavior of the function. Now you say the answer is going to be 1/2 times square root of infinity is again infinity. 2 times infinity is again another infinity. So this is 1/infinity. Now one thing that you must also know is that the constant c divided by a very large number, constant c divided by a very large number becomes 0. It leads to 0. But constant c divided by a number that becomes 0, that becomes very small number. The answer will be an infinity or negative infinity. But if one of them is positive or negative, one of them is negative or positive, then you will produce a positive or a negative infinity there as well, depending on the signs that are here. Okay? So this will be the answer. And now we write the answer in terms of intervals now. We say that range of this function will be that y is between 0 and infinity. You can write it using this notation, or you can say y is an element of all numbers that exist between 0 and positive infinity. Writing this and that is the same thing. So you choose one. You can write with either way that you prefer to write. Okay. Here is how the sketch of the function looks like. Okay. So you can see as we go to positive infinity of x on the x-axis, as we go to positive infinity, we approach 0. The function keeps on decreasing. But as we go to 0, the function goes very high. That is remember our limit as we went to 0, it was going up. But as we go to positive infinity on the domain and range to 0 for the following function. Function is given by y as a function of x sine x over x squared minus 1. According to what we discussed in the beginning of this video, if there's no square root, then we don't have a problem. Our problem now is only this one here. Our denominator is dependent on x, okay? Our denominator is given by x squared minus 1. We don't want it to be 0, okay? Now it means open the two brackets for difference of two squares, x and x, plus minus 1 and 1 can never be equal to 0. It will be equal to 0 only if x is minus 1 or x is 1. So you don't want your x values to become x as 1 or x as minus 1, because those are the values of x that will make this thing here to be undefined. Okay, this thing as I mean the whole function to be undefined, because if you can get a 0 as the denominator, we have undefined solution. Okay, now let's look at the numerator of our function. You must always check sine x is going from 1 to minus 1 for all the values of x. Okay, it keeps on going from 1 here, positive 1, and minus 1 there. The value there minus 1, the value there positive 1. Now sine x will continue. There's no restriction for sine x. Okay, now this means we take that domain of sine x, we combine it with the domain that we got from the bottom function here, and say x is an element of all real numbers, but x can never be minus 1, or x can never be again 1. You exclude only those two. Okay, this is your answer for domain. Now let's look at the range. Now what's going to happen with the range? We take the limit. As x goes to the following values. We check the limit as x goes to negative infinity. The only way to attack negative infinity is from the right. Now there's no need for us to indicate. Now we again want to check what's happening at -1, what's the behavior of the function at -1, both from the right and from the left. And then we want to check, and again we want to check what's the behavior of the function as x goes to +1, both from the right and the left. And then we want to check at infinity what's happening. The only way to attack infinity is just from the left. There's no other way. We cannot go to infinity from the right. Okay. Now we're going to check the limits at those all those values and then compare what's happening with the behavior of the function. Now we say for range, we are going to take all the conditions that we are going to produce here. Okay. Now let's take the limit of this our function, the limit of y, that is sine x over x squared minus 1 as x goes to minus infinity. As x goes to minus infinity, what's happening with the graph of sine? I'll just sketch it here, I'll raise it quickly. The graph of sine looks like this. Remember I told you that it will always be a number that is between -1 and 1 there on top. Now it's just a constant. Sine x will remain to be a constant that is in between -1 and 1. Now you want to divide that constant with what? When we go to negative infinity, this x squared becomes, you replace x with negative infinity and it becomes positive, very large number that is infinity. Now that infinity, you subtract 1 from it, infinity subtract 1 is again what? Infinity. It's a very large number. Subtract 1, you're going to produce a very large number again. So we have there c divided by a very large number, and the answer for this is just 0. Okay? And now we say at negative infinity, the answer is 0. Okay? Now let's approach -1 from the right. The limit of f of x as x goes to -1 from the right. Or let's check it from the left first. From the left, so we go in order from the left, then we go to the right of -1, and from the left of 1, like that. Now let's go of sine x over x squared minus 1. Okay? Now, this is going to be what? This is going to be nothing but sine of -1. That is just sine of 1, that is negative. Negative sine of 1. And then over, you put -1 as your x. But you are coming which side of -1? You are coming this side. These numbers that are to the left of -1 are bigger than 1 in terms of magnitude. We are scoring these values here as our values of x, and what do we produce? What we produce is a positive very small number. Now we produce a positive very small number. I'll just abbreviate like that. I want to make it clear to you, you only end here in exam. This is what you write. All the things that are above this line is what you're going to write in exam. Okay, now this one is just an interpretation. I'm just interpreting my imagination to you. How do I get the answers in exam? Now say negative constant, that is negative sine of 1. It's just a constant, and you want to divide it by a positive very small number. Why is it a positive very small number? Because these numbers here are bigger than 1 in magnitude, remember? So we square them, they become something that is bigger than 1. We subtract 1 from that. So we keep on approaching 1, doing that thing of subtracting 1 from a positive, a number that is bigger than 1. But the answer will be approaching what? The answer will be approaching a 0. Now as it approaches 0, what we produce? A very small number that is 0. So I'll write it like this: minus constant over so-called 0, a number that wants to become 0. Okay, you don't do this in exam, it's how you interpret in exam, and therefore the answer will be negative 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 infinity. That very small number goes into C so many times. It goes so many times, infinitely many times into C. Okay, now that's how you produce the answer. Let's look at what's happening as we go to -1 from the right. So we saw that as we go to -1 from the left, we got a negative infinity. So we write negative infinity there so we don't forget what we got at -1. And again, we want to check at -1 again. I'm just going to write the second one below that one so that we compare everything, and then from all of those results, we can compose our we can compose our we can submit our final answer of the range. Okay, let's check what's happening with the limit of f of x as x goes to -1 from the positive side, from the right. Now from the right, we say we have just negative sign of 1 again, because we put x as -1. Remember, we divide that by what? We divide it by a very small number. This number, it wants to become 0, a very small number. But this number sign is now how? It's negative. Look at it. We have here, we have -1. Here is 0. All these numbers that are in between here are just smaller than 1 in magnitude. And when you want to square them, they cannot be greater than 1. The answer cannot be greater than 1 as we put them as our x values here. Now, since they cannot be greater than 1, we subtract 1 from there. We get a negative number that is very small. Now we get negative divided by negative is positive, and therefore the answer is positive what? Positive c divided by a very small number, positive infinity. Okay? And in exam, what you do is you only write this answer as positive infinity. You don't write all these things that I'm writing here. All that things, my imagination is how I imagine in exam. If you don't want to imagine these things in exam, you can just do it as your rough work. Somewhere, write it somewhere, not in your exam, in your answer script. Okay, you want to write it somewhere aside and then interpret from there. Okay, now let's go to +1. Let's go to +1 from the left. Okay, of this function, what do we produce? We produce sine of x is now 1. We produce uh, we want to put here the values of x that are approaching what? Approaching 1. If they're approaching 1, then we'll have 1 minus 1, that is 0, a very small number. Now, how is the sign of this small number? Let's go and figure it out. Here is 1. We want to come from the left of 1. These numbers that are in between 0 and 1 are very smaller than 1. And when we square them, they cannot exceed 1. They will always be smaller than 1 as well. Now we say those numbers, subtract 1, subtract this one from them. As we subtract that one from them, they become very negative small numbers. Okay. Now we just divide C by a negative small number. Okay. The answer here will be what? It will be positive divided by negative, negative. That very small number that wants to become 0 goes into C so many times, infinitely many times, and the answer is therefore negative infinity there. Okay, so we know that it will be negative infinity as we go from the left, negative infinity. And then let's go from the right. Let's go from the right of this +1. Let's go from the right of +1 and find the answer. Now, as we do that, all these numbers that are in between maybe 2 and 1, they are very large than 1, and when you square them, they are going to produce a magnitude that is bigger than 1. Subtract 1 from them, you get a positive, very small number. Because we keep on doing this thing, we say the limit as we approach 1 from the right. This means we keep on substituting. We substitute 2 first, and then substitute 1,5, and then substitute. As we do that, the number is going to be is going to shoot very high and be a very large number. Okay, now it's going to be sine of what? Sine of 1, that is just a constant c, divided by what? Put those small numbers there, they will become positive because we have a large magnitude than 1. Subtract 1 from it, so we get a positive number. And then but this number, we keep on going towards 1. This number is growing small. It's going to be a very small number. And now it's just c divided by an imaginary 0 there. What is the answer? The answer will be infinity. So we just put infinity there, and therefore For at 1, we produce two solutions that are minus infinity and infinity, as well at both 1 and minus 1. Now let's look at infinity, what is happening with the function. Now we want to check the limit of f of x as x goes to infinity. It's only from the left, unfortunately. We cannot check it from the right. We check it like that, and we put sine of that infinity is just going to be a constant ranging from minus 1 to 1. That constant ranges from minus 1 to 1. We want to divide that constant by what? We want to divide that constant by x squared minus 1. Infinity squared minus 1 is again infinity. Infinity squared is infinity minus 1. We are not changing anything. It's like this one is worthless. Subtracting the one was just useless. So we end up with infinity as well. But now we are dividing this constant that is ranging between minus 1 and 1 with this large number. So c divided by a very large number becomes what? It becomes 0. And therefore, there we have 0 there as our answer. Now let's compose our range based on those 6 values that we got there. When you compose our range for this function, we say for range y is going to be a number between what? Let's check. A very small number between all of them here is just minus infinity. And then a large number between all of them here is infinity. So it will range from infinity. We can even imagine the function here. Let's look at the rough sketch of this function. It will look something like this. We have minus 1 there. We have 1 there. Okay. And let's don't forget to draw our vertical lines, because now it's like we are sketching a function with asymptote at minus 1 and 1. Okay. It's asymptote. Now we want to go to negative infinity. As we do that, the function goes towards 0, and as we go to minus 1 from this side, what's happening with the function? It goes to negative infinity. So we know that the function here looks like this. Okay, it goes that side and it goes down as well. And now at 0, if you can check at 0, you have sine of 0. Sine of 0 is 0 divided by minus 1 is 0 again. So the function will come and touch here. As we go to minus 1 from this side, what's happening with the function? It's going to infinity. The function goes up like that. As we go to positive 1 from this side, what's happening with the function? The function goes to negative infinity, so it must go down like that. And then as we go to 1 from this side, what's happening with the function? It goes to infinity, it goes up like that. And as we go to 0, as we go to infinity, I mean, the function goes to 0. The function goes to, it wants to become 0. It approaches the line y equals to 0, that is our x-axis. And therefore, the function looks something like this. Okay? I'll just show you now in a moment. There's a function. Now let's look at it. Let's look at how the other way to write this range that we got here. We write y an element of, you exclude minus infinity, you go up to infinity. So you can see if you place our ruler here, we want to take this our ruler up. Our function exists from minus infinity. Even at 0 it exists. Why does it exist at 0? Because of that point 0 is to 0. Now we again move up like that to positive infinity. So we are from negative infinity to positive infinity. And that's why this is the other way to write the very same solution. That is our range. If you write like this, you get marks. And other person comes and write like this, they also get marks. So it's the same thing. Okay? There's no problem. Before we look at our next problem, let's just do this checklist quickly. Like the video that you are watching and share this video with your friends, please. Okay? Okay, our bonus question here says find the domain and range for the following function. You want to find the domain and range of this function. F of x equals to the square root of 3 minus x minus 5. For the domain, The minus 5 is just a constant. It does not have x. So uh, we are not involved there. We don't want to invite trouble. We just say 3 minus x. If you look at it, is the first case that we discussed in the beginning of this video. Okay, in the beginning of this video, remember we said we check the square root and the denominator, the two most important things that they like to assess. Uh, Unfortunately, this video is so long now that I have to cut it short, and we will look at more problems, but the absolute values problems in the other video that I will just create in future. For now, let's just end the video with this question, our bonus question here. And if you're struggling to solve the inequalities, especially those of quadratic, please refer to this video up here. It will really help you a lot, okay? This 3 minus x that we discussed in the beginning of the video is inside the square root. Now we have to make it to be greater but also equals to 0. And then solve this will be greater but also equals to x. 3 will be greater but also equals to x. This simply means that x should be less but also equals to 3. Rewriting it in standard form, a normal way to write it, a beautiful way to write it is this one. Okay, you impress the mark. Now after doing like this is just your domain. The way it is just your domain. Now let's look at the range. The range, we want to take the limit of f of x. Now this the domain says it's sometimes impossible for you to find the range without finding the domain first. And that's why it's always important to find the domain. Here is our 3. We want to include it. We know the function is going to exist to the left of 3. Okay? Now we want to check our range. As x goes to, that's 3. We want to check the behavior as x goes to 3 from which side? From the negative side, from the left. Okay? And then we want to again check the behavior of the function as x goes to negative infinity. Unfortunately, negative infinity, we just check it from which side? We just check it from the right. Okay? For range, you say find the limit of f of x as x goes to negative infinity. Now f of x is just the square root of 3 minus x minus 5. Put your negative infinity as your x, you get the square root of 3 plus infinity, okay, minus 5. 3 plus infinity is just infinity. Square root of infinity, infinity. Minus 5 is like you didn't do anything, and therefore the answer for that will be again positive infinity. So we know we can sketch the function now. If we can just find the limit as x goes to that 3 from the left, we can sketch the function. Let's look at it and say find the limit of the function as we go to 3 from the left. What do we get? What we get is limit is going to be 0 minus 5, because 3 minus 3, 0, square root of 0, 0, and then the answer is just minus 5. Now we know that the limit as we go to 3, from the left of 3, we are going to minus 5, and therefore we can do a rough sketch there. There is 3 and there is minus 5. Here is our point, and then we don't know where it's cutting, but we can check where it's cutting. When our x is 0, our y-intercept is going to be square root of 3 minus 5. Square root of 3 minus 5 is a negative number, so it will cut here. The square root of 3 minus 5, negative number is there. So we must come and cut there and then go that way. Okay, and that will be our function. That's how it looks like. As you can see on the computer sketched graph here, you can see that it's a function that looks like exactly the same one as that one. Okay, now we are done with this video. Thank you very much for watching. If you are looking for more videos, please feel free to comment on the comment section of this video, and then we will see how we do, because We are still busy working. We are working with the videos. We are working with the semester this side. It's complicated, but we will manage, guys. Let's just keep on pushing and make the best out of this year. Okay. Good luck with everything you do. Bye.